This is a callback. Yeah. Hello, everyone. Thank you for joining us. I'm Steve.
And I'm Scott.
And together we are Backyard Musing Broadcasting Live, Apple Valley, California.
And we are the Science and Technology Marathon Channel.
This is an interesting subject here. My wife sent me this, and so she's not getting any royalties. We don't get paid, so she's not getting paid.
I have an old friend that would benefit from this. Yeah.
Scientists have found a way to restore the brain and spinal cord interface, developing an implantable device that enables paralyzed patients to stand and walk again. So think about it. The spinal cord is cut. So they're doing a bypass.
Right.
So that the brain can still communicate with stuff
below
the cut. Right. A spinal cord injury can be debilitating for some people, making it difficult for them to walk normally again. Some individuals may take weeks to recover their ability to walk after an injury, while others may take months or even suffer from paralysis. As per the official release, quote, the findings establish a framework to restore the natural control of movement after paralysis. The study is led by neuroscientist Courtine from the Ecole Polytechnique Fe de Lausanne in Geneva, Switzerland. Would you like to know more?
Paralysis is mainly due to the spinal cord injury hindering communication between the brain and the region of the spinal cord responsible for limb movement. Scientists have found a way to restore the brain and spinal cord interface, developing an implantable device that enables paralyzed patients to stand and walk again.
Amazing.
Yeah, miraculous. To walk normally, the cortical area of the brain sends signals that are picked up by neurons in the lumbosacral region of the spinal cord to initiate muscle movement.
Most spinal cord injuries do not directly affect these neurons, but they are capable of disrupting the descending pathways that allow brain-derived signals to reach these neurons. This new brain-spine interface, BSI, device, according to the study, consists of fully implanted recording and stimulation systems. The electrode-based device is made up of several components that allow for the recovery of leg movements, such as a processing unit to predict movement intention and a pulse generator for simulation. The device is implanted in the cortical region of the brain. This part of the brain converts movement instructions into nerve signals.
Quote, to establish this digital bridge, we integrated two fully implanted systems that enable recording of cortical activity and stimulation of the lumbosacral spinal cord wirelessly and in real time. That was noted in the research paper published in the journal Nature. According to the authors, the device worked to reestablish the brain-spine interface in a patient with chronic tetraplegia, upper and lower body paralysis.
Yeah, that's like quadriplegic, yeah. Tetra is 5, isn't it?
I don't know.
Okay, here's how the author explains the research. This is like from the abstract. A spinal cord injury interrupts the communication between the brain and the region of the spinal cord that produces walking, leading to paralysis. We restored this communication with a digital bridge between the brain and spinal cord that enabled an individual with chronic tetraplegia to stand and walk naturally in community settings.
Fantastic.
Yeah.
This brain-spine interface consists of fully implanted recording and stimulation systems that establish a direct link between cortical signals and the analog modulation of epidural electrical stimulation, targeting the spinal cord regions involved in the production of walking.
A highly reliable BSI is calibrated within a few minutes. This reliability has remained stable over 1 year, including during independent use at home. The participant reports that the BSI enables natural control over the movements of his legs to stand, walk, climb stairs, and even traverse complex terrains.
Man, I'm getting emotional about this. This friend of mine would be correct. This would be remarkable.
Yeah.
Moreover, neurorehabilitation supported by the BSI improved neurological recovery. The participant regained the ability to walk with crutches over ground, even when the BSI was switched off. Wow, that's crazy. So it's like a memory type thing, right?
Yeah.
This digital bridge establishes a framework to restore natural control of movement after paralysis.
Yeah.
Wow.
This is groundbreaking. It's crazy.
Yeah. I mean, this guy, I've known this guy for over 40 years, and he's been paralyzed from the waist down, been in a wheelchair. And if you heard his story before he was paralyzed, this would be perfect for him. I mean,
They're probably going to need something like that. You need to build up muscle that hasn't been
Right.
used for 40 years, you know,
Right.
but
right,
eventually, you know, after training and therapy and working,
yeah, this would be
game changing.
oh, amazing. Just amazing. Life changing.
It's amazing what our scientists are doing, and not our, but what scientists are doing and studying and researching.
Yeah.
It's just every story we come out with is just amazing, you know.
And why did they come up with this kind of stuff? Do they have a family member or a friend that this happened to?
What's their passion?
Yeah, they're passionate about it. So
yeah,
grateful for that. Definitely grateful for
definitely
that.
a lot of people. Yeah.
Yeah.
Thanks for joining us, folks. We really, really appreciate it.
Take care, everyone. Thanks.